I teach ELA, but I also teach science. It's a middle school, so we're going to switch gears to science. And typically, this will be something that I pass out to my students and they put in their interactive journals. And I always do it on color-coded paper for different units so that they can just look in their journals and see right away, oh, that's my stuff on weather or climate or
how many colors?
Ecosystems. I do have to double up throughout the year, but I try to make it make sense. So this lesson, we've been talking about weather. We've been talking about climates. And there's a huge difference between the two, right? I know that there's going to be a little gap here, you guys, but let's consider this for a moment. What I want you to do is I want you to take a look at these first 3 questions on your worksheet. What is the greenhouse effect? We studied this when we were studying atmospheres, right? What is the greenhouse effect? Is it a good thing? Is it a bad thing? Or both? And then the next sentence, or question, what does global warming mean? We hear it all the time. Global warming. Well, actually, we don't hear it as much anymore as we used to. When I was your age, we heard it all the time. Now we hear something different. We hear climate change, which takes us to the next question, which is, what is climate change? How is that different from global warming? I'd like you to take a minute to take a look at those questions and write down what you think now. What do you think now? Right. Looks like most of you have something down there. So, who's feeling brave today? I know we're pulling on some information that we covered in some units past. Who wants to tackle the greenhouse effect? Do you guys remember the greenhouse effect? What do you think the greenhouse effect is? Yeah.
Isn't that putting a lot of CO2 in the air, like carbon dioxide?
Maybe. Does anybody have anything they want to add to that, or you want me to help you out? Yeah.
Does it have to do with methane gases, maybe? Acting like a greenhouse and keeping heat in?
You guys are on track, because it has to do with the ozone layer in our atmosphere, right? And those gases that you're talking about, they go up and they deplete the ozone layer. Now, what do you think? Is the greenhouse effect bad? Is it good? Is it something, what do you think? Good, bad, 50-50. Low stakes here. What do you think?
I think of pollution when I think of greenhouse gas effect.
So you think of pollution. I'm going to do a quick review of the greenhouse effect for you guys, okay? So the greenhouse effect is good. It's very good. Without it, we'd all be dead. So the greenhouse effect is a natural occurring thing that happens in our atmosphere. And it keeps us warm. If we didn't have the greenhouse effect, we'd all be frozen people, right? We'd be dead. There's no way we could live. No living organisms would exist on Earth without the greenhouse effect. So in a sense, that's a common misconception. People hear greenhouse effect and they're like, whoa, ice caps are melting. Now, let's roll that into greenhouse effect, definitely good. Let's roll that into our second question that you guys just took a look at it. Global warming, what do you guys think that means? What do you think that means? Global warming. Nobody's brave now because I did greenhouse effect first. Yeah, Ian.
I think it means that the overall temperature of the Earth is increasing, which is causing.
Excellent. Perfect. You brought in some good vocabulary there. You said the overall temperature is increasing, right? I'm going to move it over here. So the temperature is going up. That is exactly what that means. Now, if you have global warming, meaning the temperature is rising, you have greenhouse effect, which is what's keeping us warm. What do you think climate change means? Climate change. Why do we even have that terminology now? Yeah, Marjorie?
Is that a broader pattern of changes in the weather? Like we're having more severe, more frequent storms, more severe droughts, really extreme winter weather?
Yeah. So, global warming was great. You're absolutely right. Global warming was great when I was a kid, because I'm old now. But it was great when I was a kid because scientists were looking at this and they were seeing a trend of temperatures all going up. And the ice caps are melting, problems are happening, Venice is sinking, right? They had to change it to climate change. They had to change it to climate change to include places that the temperature wasn't rising. They had to change it to climate change to include wild, crazy weather that we were experiencing, possibly due to man-made things, possibly natural. The problem with this is a theory. What is a theory? Somebody help me out with the theory. What's the difference between a theory and strong factual evidence, something that's been proven? What's the difference? You had your hand up. Someone.
I think it's a hypothesis that's been tested multiple times with evidence.
Yes, but has it been proven yet? It hasn't been proven yet. And the reason that climate change is something that hasn't been proven yet is because they have to take data that spans an enormous amount of time. Now, does that mean they're wrong, that there is no climate change going on? No. But does that mean they're right? Not necessarily. We need more time and more data to articulate where we're at with this. So let's keep going, and let's take a look at our learning target for today. The learning target is I can identify, and it's on your sheet too, and represent the relationship between our keywords here, climate change, global warming, and greenhouse effect, right? So identify. What does that mean? We got a spot there for you guys to write some things down. We identify a lot in our science class. What do I mean when I say identify?
Locate a name.
Locate a name, perfect. So as I'm writing things up here, you can write it in that space. Oops.
Oh, and name. That's
Yeah, sorry, I have issues sometimes. I do this on a smartboard presentation, I just kind of pull everything down. And represent, if we locate it and name it, we identify it. Now we want to represent something. What does that mean? How can we represent things in, show? We want to show it. And how can we do that in science class? What do we use? What do we use to show? It's the same as ELA, you guys. It's okay. Beautiful. Diagrams and graphic organizers. Graphic organizers and diagrams. We use those all the time. So what I want you to do is take a minute, rewrite the learning target in your own words. Think about it. And then we'll move on. Bless you. So, I'm going to show you guys a bit of a video. It's very exciting. Take a moment, direct your attention up there.
Much of Greenland is covered with an enormous ice cap, the last of the great northern ice sheets. The ice is over 2 miles deep, and the bottom is made from snow that fell about 250,000 years ago. American and European teams collected ice cores here that have revolutionized our vision of climate. The ice cores were sliced up, and every aspect was scrutinized in detail, from their crystalline structure to chemical content and electrical conductivity. In this test, 2 electrodes are dragged across a clean surface of the ice core. The readout reveals fluctuations in atmospheric dust content. A dip on the graph indicates more dust and a drier, colder climate. Climate experts used to believe that the warm-up after the last ice age was slow and steady.
So for time purposes, you guys, I am gonna stop this. And I'm gonna direct you towards your worksheets without saying anything else yet. We do this quite a bit. You guys have a stack of Post-it notes in your lab kit on your table. Take the Post-it notes, and in the space in your worksheet, I want you to write down the 3 key ideas that you heard from the video. Very hard to do since I cut that off, isn't it? So I'm gonna move forward and kind of give you guys some information because it's a fairly decent size video. But basically the video goes over how they test ice to determine, you can tell by the crystals in the ice and how it's been frozen, how cold it was, and you can tell how warm it was and whether there were large storms. You can tell all kinds of things from frozen water. It's fantastic. It's amazing. So I'm not going to make you tell me what's on those things. If you were in my class, I would, but that would be really hard. So you were looking for the big idea or the main focus of the video. And I hated this, but typically I would have you guys share that with a partner, an elbow partner. But we're going to move on to this next thing. I think you can do this even though we didn't watch the video. The next part is with your elbow partners. In my class we sit at tables, 4 to a table, so just partner up here. I want you guys to answer the following questions now that we've gone over a few things. There's the greenhouse effect in there, whether it's natural, man-made, or both, which they go over in the video. Greenhouse effect is both natural and man-made. It's a hint for you guys. And global warming and climate change. I'll give you guys a minute or 2 to do that.
Okay, for the greenhouse effect, the ozone layer is keeping in heat and it keeps us warm.
I have exactly the same thing, but I said warm and alive.
It's both man-made and natural.
Ditto. So, global warming, that's the overall increase in temperature, averages.
Yeah, so a lot of cows on this one.
And then climate change covers extremes, not just increases. Yeah.
And it's like over time.
Mm-hmm. Yeah, that's a good point. Over time.
Extreme weather patterns.
Alright, you guys, so I am going to interrupt your process there because I only have a couple minutes and I want to just zoom through a couple things with you. If you probably can't tell, I do a lot of collaborative work in my science classrooms. We do a lot of elbow partners and we also do table partners. So what you would be doing is you'd be working on these questions with your elbow partners or paired up. And then you would answer some questions, and it's kind of like a student voice. How do I feel about this? And they're on there as well. Can I identify these things? But then we move on and we continue to explore it, and we do this in more little elbow partners, but then we do our tables, and we revisit our learning target, identifying, representing the relationships, and then we do a concept map. The concept map is a little bit different because I give the students, I have laminated in my classroom a bunch of